Sai Ram students, welcome to the fourth session of chapter 14, that is elements, compounds and mixtures. So before starting today's session children, let's revise what we had learnt in the last session. So children, in the last session we had seen what is a compound. So the substance which is formed by the chemical combination of two or more elements is called as a compound, right? So we took the example of water, carbon dioxide. So water, the molecular formula is H2O. So two molecules of hydrogen, that is two atoms of hydrogen and one atom of oxygen, it forms water, that is H2O. Similarly for carbon dioxide also, one atom of carbon and two atoms of oxygen, it forms carbon dioxide. So hydrogen is an element, oxygen it is an element, but when they combine together it forms a compound called as water. Now hydrogen, it is a combustible substance, that means it burns. Similarly oxygen also, it helps in the combustion, but the compound which is formed by combining both these elements, water, right? But water, it does not help in burning, but it is used to extinguish the fire, right? So water is a compound which is used to extinguish a fire. Now these molecular formulas also, they are written in the short form, like we for elements how we use the symbols in the same way. So we took some examples like sodium chloride, that is NaCl, then acetic acid, that is CH3COOH, right? So some examples we discussed about the molecular formula. Then we saw children about what is a mixture. A mixture, it is formed by mixing different elements or compounds. Now whatever components, various components which you used in a mixture, that proportion is not fixed, and in the mixture no new substances form and no chemical change also take place. Now if you want to separate some unwanted ingredients from the mixture, then you can use different techniques. So we discussed like winnowing, filtration, churning, then picking, separation, right? All these and sifting. So all these methods were used for separation technique. Now today we'll see about some more techniques of separation. So let's see. Now in the figure you can see here children, it is a distillation method, right? So distillation method, this is used for the purification of impure liquids, right? So now you can see over here in the figure, right? This is a stand, right? Now this stand, what you can do, this is a stand. Now this is a round bottom flask, this is a inclined tube, right? And that is called as a condenser, right? This tube, it is inclined, so it is called as inclined tube, and this is the condenser, and this is the conical flask, and a thermometer is also used over here, right? So what is this distillation method? How you are going to separate it? So let's see about it. So what you have to do, you in the round bottom flask, you have to take a mixture of salt and water. That means you have to mix both salt and water, and you have to take this mixture in the round bottom flask. So you can see here in the round bottom flask, it is the mixture of salt and water. Now to this you have to attach a thermometer, and then you have to heat this round bottom flask. On heating, what will happen? The solution, it will start boiling, and then the water which is present in this salt water, it will start evaporating, right? So it will vaporize. So what will happen? The vapors which are there, it will come upward, and then the vapors, it will pass through this inclined tube. Now this is the condenser. Now this condenser, if you see children, this condenser, it is surrounded by the cold water. So what will happen? The vapors which are present in this inclined tube, because of the surrounding cold water, what will happen? The vapors, it will get transformed into water, and then drop by drop the water will get collected in this flask, right? So this is the distillation method which is used for separating the impure liquids. So let's see. Now the salt water which is there in the round bottom flask, it boils on heating, and then what happens, water which is present in this salt water, it will vaporize, and then the vapor, when it passes through this inclined tube, what will happen, the condenser, in the condenser surrounding there is cold water, so the vapor, it will get cooled and then it will condense to form a water. That means from gas form it will get converted into a liquid. Thus the drops falling into the conical flask are of the water from the salt solution in the round bottom flask. So whatever water is getting collected in the conical flask, it is the water which was there in the round bottom flask, which was containing the salt water, right? So what will happen, the salt will remain behind at the bottom of the round bottom flask when all the water has collected in the conical flask. So salt and water, it has been separated. Water, it has been collected in the conical flask, and salt, it will remain in the round bottom flask. So this method is called as distillation, and distillation, it is also used for the purification of impure liquids. So I hope students, you have understood the distillation method. Now we'll see the second method, that is the separation method. Now in this separation method, you can see here children, this is a stand, right? This is the separating funnel, and this is a beaker. This is a stopcock, right? So what you are going to do children, you are going to take this separating funnel, right? And this separating funnel, what you will do, you will pour a mixture of kerosene and water in this separating funnel, and then you will close it with the stopcock, right? So and then you will fix this separating funnel to this stand, right? And then you will keep this in the this position without touching it, right? And that means you will leave it undisturbed. Undisturbed means you are not going to touch it, you are going to keep it in the same position as it was kept without touching it. After some time, what do you see? You will see that you will see in the separating funnel there are two layers. One is of kerosene and the other is of water. So water, it will get collected below, and kerosene will float on this water, because water, it is heavier than kerosene. So water is heavier, so it will be in the bottom, and kerosene is lighter, so it will float on the water. So you will do two separate mixtures, you will see, right? Two separate layers you will see. So once you see this, what you will do, you will open this stopcock, and then in the beaker, you will open the stopcock, and the water, it will start falling drop by drop in the beaker, and you have to wait till the water gets collected in the beaker. So what will happen, and then you will again close the stopcock once the water has been collected in the beaker. So what will happen, only kerosene, it will remain in the separating funnel, and water, it will get collected in the conical flask. So now let's see in detail. When a mixture of two immiscible liquids is left undisturbed, two layers are clearly seen to have formed. So two immiscible liquids means liquids which do not, which are not soluble, which do not mix with each other, like your water and kerosene, right? Because kerosene, it will float on water, it will never mix with, it will not be soluble with water, right? So if you leave them undisturbed, what will happen? You can see two different separate layers. So the heavier of the liquid, it remains below, and the lighter liquid floats on it. So as I told you, water, it is heavier than kerosene. So water, you can see below, and the lighter liquid, that is the kerosene, it will float on water. So two liquids in a mixture can be separated by making use of this property. So by using this separating funnel, we can separate two liquids in a mixture. Now this is the centrifuge. Now this is also one method of separation. So you can see here children, this is the electrical centrifuge. So these are mostly seen in the laboratories, right? scientific laboratories or in the factories where R&D centers and all are there. So here what is done, now some liquids are there which cannot be separated even after if we keep them undisturbed. Like now suppose if you take turbid water. Now what is turbid water? Turbid water is water which is not clear. Something is added to that water. Now suppose soil is added to that water, so it becomes turbid, right? It is not clear, some haziness you can see in the mixture. So what you will do now, this turbid layer also, if you keep it undisturbed, what will happen? The soil particles, it will settle down, right? And then you can see the separate water layer also, right? So that can be used as a separation. But for ink or for milk, now whatever particles are there in it, that even if you keep it undisturbed also, you cannot see that the particles which are present in the milk or in the ink, you cannot see them getting settled down, right? Why? Because their particles, they are smaller in size. That means they are very tiny, or they are lighter in size. So that's the reason you cannot see them settling at the bottom. So for these for that you have to use this centrifuge machine. So you can see in this centrifuge machine, this is the disc over here, right? Now inside you can see here this white things. These are the holes where you can keep the test tubes, right? So what happens, this centrifuge machine, it starts rotating like a fan with a greater speed, and then what will happen, the particles which are present in the ink or in the milk, it will get settled down because of the force which is generated, right? So let's see. Turbid water, ink, milk, buttermilk, blood are mixtures of liquids, and they are insoluble solids, right? So when turbid water, it is kept undisturbed for a while, the soil particles in it slowly settle to the bottom, right? So the particles of the milk or the ink, however, do not settle even on being left undisturbed. So as I told you, the soil particles, they will settle down if you keep it for some while when undisturbed. But for ink or milk, even if you keep it for some time also, you will not see that the particles have settled down. So this is because the particles of the solids in such mixtures, being very tiny and light, remain evenly disturbed in the liquid. So because they are tiny and they are light, so they are always mixed with that milk or ink. You cannot see them settling down. So these particles, it cannot be separated from the liquid even by the methods like filtration or settling, right? Even if you filter it also, you cannot see these particles. You cannot separate these particles, or it will not settle down also. So in the laboratory, a centrifuge machine is used to separate the solids from a mixture of a liquid and a solid. So this centrifuge machine, with this you can separate this mixture of liquid and solid. So it consists of a disc which rotates like a fan at a great speed, and there is a provision to attach test tubes at the rim of this disc. Rim means at the edge of the disc. So as I showed you over here, this is the edge of the disc, right? So the test tubes are just kept at the edge of the disc, right? When the tubes attached to the disc rotate at a high speed, a force is generated which pushes the particles away from the center. And as a result, the solid particles in the mixture in the test tubes, they collect at the bottom of the tube and are thereby separated from the liquid. So because the disc, it rotates at a high speed, force is generated, and what happens, the particles which are present, it gets pushed away from the center, and then they collect at the bottom of the tube, and then we can separate this liquid and the solid, right, or the particles which are present at the bottom by the method of centrifugation. Next is chromatography. Now chromatography is also a technique by which you can do the separation. Now you can see over here, children, this is a this is a beaker containing water, and this is a filter paper, right? So what you are going to do, you are going to take a filter paper of rectangular size, right, and then you are going to put one blue spot of ink on this filter paper at a distance of around 2 centimeter, right, starting from the at one edge, right. So this is one edge and this is the other edge. So at the other edge you will put this pot of blue ink. Now you will keep this filter paper in the beaker containing water. So in the beaker you are going to take water and then you are going to keep this filter paper in the beaker in the upright position. That means the spot of the ink, it will be down in the water, and then you will place the lid with the on the beaker, right, and then you will wait for some time. So after some time, what do you see? You will see that the blue spot of the ink which is there, it has risen up, right, and it has reached at a particular height over here, right. So this blue spot of ink, it has risen up and it has reached at a particular height. So children, you all know that this ink, it is a mixture of a dye of 2 or more colors, right. So by using this filter paper or this chromatography method, if the ink, it contains 2 or more colors, that also can be separated by using this chromatography method. Like suppose the ink, it contains red and yellow color. So what will happen? It will the spot of the ink, it will rise at a particular height, and you can see 2 different colors of the ink, that is the red and the yellow color, right. So by using chromatography method, we can do separation also, right. Now what is there in this chromatography method? If 2 or more substances, they are dissolved in the small proportions in the same solution, these substances, they are separated from each other by means of chromatography. So if 2 or more substances in smaller proportions, they are mixed in one same solution, you separate them by the means of chromatography. So this method, it is used in pharmaceutical science, factories and scientific laboratories for detecting new ingredients and for identifying and separating components of a mixture. So this chromatography method, it is used in pharmaceutical laboratories, factories, scientific laboratories also, right, for identifying and for separating or detecting new ingredients in a mixture. In this method, 2 properties of a substance are used. These are the solubility of the substance in the solvent, that moves up the ability of the substance to stick to the stationary filter paper. So these properties, they are mutually opposite and are different for different substances, right. As a result, all the components of the mixture do not rise all the way to the upper end of the filter paper, but remain behind at different heights. So whatever components are present in the mixture, it's not necessary that all will rise at the upper end of the filter paper, but it will rise, but it will be at a different heights, right. So by using this chromatography method also, we can separate the mixtures, right. So children, with this we finish chapter number 14, that is elements, compounds and mixtures. So let's recap what we have learnt in today's session. So in today's session, children, we had seen different methods of separation. First we saw the method of distillation. So distillation method, it is used also for the purification of impure liquids. So what happens in distillation method? Now we had taken salt water in a round bottom flask, and what happened? The salt, it remains in the behind the round bottom flask, and the water it get on heating, it gets converted into vapor, and this vapor, it passes through the inclined tube, and because in the condenser the surrounding water there is cold water, the vapor, it gets converted into a liquid, and then it gets collected into a beaker which is kept down. So with this salt and water is separated, that is salt remains in the round bottom flask and water, it gets collected in the beaker, right. Then the second method we saw about the method of separating funnel. Now what happened in separating funnel? We took two different liquids, that is water and kerosene, and then we left it undisturbed for some time. So what happened? The water, which is heavier, it remains at the bottom, and kerosene being lighter, it floats on the water, right? So you can easily separate water in the beaker, and the kerosene, it will remain in the separating funnel, right? So this was one method of separation. Then third method we saw, the method of centrifugation, right? So whichever method, like the method of separating funnel or filtration, we cannot separate the liquid, the solids or the particles which are tiny and light, which on keeping undisturbed also you cannot see the layer settling down. So for that method, centrifugation method is used. So these are usually used in laboratories, right? So what happens in that, the test tubes are there, and in that test tube the mixture is kept, or the liquid is kept, and then it rotates at a greater speed, and then force is generated. So after the force is generated, what happens? The particles, they push away, and then they get collected at the bottom, right? And the liquid, it will remain up, right? So by centrifugation method you can separate the liquid mixture also. And the last method which we saw was about the chromatography method. So you have to take a filter paper, make a blue spot of the ink on the filter paper, that is rectangular filter paper, and then you have to place it in a beaker containing water, and then you have to cover the beaker, right, with a lid. So what will you will see after some time? You will see that the blue spot of the ink, it will risen up at a particular height, right? And then so the whatever component of ink is present, whatever different color which is present in the ink, right, that will get separated. So if two colors are present in the ink, you will see two different substances on the filter paper at a particular height. So chromatography is also one of the method for separating the mixtures. So children, in the next session we'll start with the new chapter. Till then, goodbye.